Well, hello there, kids. Here we are with section 5.4, still factoring, still using trinomials, but this time things are just getting a little bit deeper, a little bit scarier, a little bit more trouble. We're going to look at situations where our factoring that we were doing before just isn't going to quite work out for us. Are all quadratic trinomials going to be factorable? Well, not necessarily. Sometimes we're going to have to manipulate them around and make them into something that we're going to be able to factor. So, here we are in 5.4, a couple of questions there in your homework packet that you can take a look at later on. So, looking at this guy here, 8x squared minus 18x plus 9. What are we going to do with that 8? Well, you got to think about what multiplies an 8. 1 and 8, 2 and 4. What multiplies to make a 9? You got 3 and 3 or 9 and 1. You start getting lots of different combinations that you're going to have to use. And if you're sitting here trying to do a box method with that, not only do you have either 8x and 1x to try to get your 8x squared here, you got your 4x and your 2x. Then you've got to worry about this. So you've got 9 and 1, 3 and 3. Well, maybe the 9 goes down here and the 1 goes up here. There's a lot of different possibilities to sit there and check and check and check and check. So we've got a method to just kind of work through it step by step and take care of that for us. Going to call it the AC method. It comes from our form being the ax squared plus bx plus c. Well, in this case, the 8 is our a and the 9 is our c. So it's called AC excuse me, method, because we're going to take that front number and that back number. First thing we're going to do here is we're going to multiply them. 8 times 9 giving us 72. Then we're going to take that 72 to the side and we're thinking about what things multiply, product, to make that 72, and what things are going to then add and subtract up to make that negative 18. So as we're looking through that, 6 and 12 are going to be those two numbers. Negative 6 and negative 12 multiply to make the 72. They add up to make that negative 18. So it's sort of like we take that negative 18 and we split it into those two terms. The front's still the same, the back's still the same. It's just that 18 that gets split into two parts. What that allows us to do is then factor each of the two parts separately, and this should start to look a little bit familiar to stuff we did before. What do the 8 and the 6 have in common? Well, they have a 2. And the nice thing about this method is both of our two things here are going to have an x, so we're almost always going to be factoring that x out here in the front. When we do this, our 12x plus 9, well, what do 12 and 9 have in common? 3. So when we do this, we're almost always going to get these two things to match up. If we don't, then we didn't do it right, or we have nowhere to go. So now our 4x minus 3, that's our first term here. Our 2x and our minus 3, second part right here. Common mistake, people forget that negative sign right there. You've got to take that with you and make sure it shows up here in your final answer. That's why I always like to circle these right here, just to make sure that we take that sign with us. Cannot leave your negative signs behind. So let's give it a shot. AC method. First thing, take that front times the back. We got 6 times 3 gives us 18. So we're looking at what kinds of things multiply to make a 18. Well, 18 and 1, 6 and 3 obviously, maybe 9 and 2. I'm kind of running out of ideas, but now we also want to make sure that they are going to add up to make that 11. Well, we've got 19 here, we've got 9, and hey-oh, there's our winner. We've got an 11. So 9 and 2 are going to be the combination that we're going to want to go with. My 6x squared, it stays the same. My plus 3, it stays the same. All that we're doing here is we're taking that 11x and we're splitting it into 9x plus 2x. 9x plus 2s, what is that? It's 11x. So all we've done is take that middle term and we split it into our two different parts. So what we get to look at now is factoring by parts. Let's factor our front part. What does 6x squared and 9x have in common? Well, they're going to have that x. The 6 and the 9, that's going to have a 3 in common. 3x times what is going to make our 6x squared? Well, that's going to be 2x. 3x times what makes the 9x? 3. So all I've done is take this front part here and factor it. just kind of like the opposite of distribution. If I took that 3x and multiplied it in, it would get me back up here to this term. So over here on my other one, I'm looking at what's going to multiply into both of these. Well, nothing. 2 and 3 don't have anything in common. 3 doesn't have an x over here on the end. So there's not really anything we can factor out. And when that situation happens, I'd really like it if we put a +1 here. This is the hardest one for kids for some reason, because it feels like there shouldn't be anything out here. We're going to put +1 and then just rewrite 2x plus 3. And hey, look at that. 2x plus 3, 2x plus 3, they match. Exactly what it was that we were looking for. So, writing our final answer. I got my 2x plus 3 as one of my factorial groups. 3x and +1 are going to combine to make my other one. So my final answer here, 3x plus 1 and 2x plus 3. I know you're really excited, so let's do another one, because this is just so awesome. Here, 12 times -6. Ah, this is just gonna, oh no. -72. There's got to be a whole bunch of things that multiply to make a -72. Definitely starting with a 72 and a 1. We know 12 and 6 has got to be in there. Oh man, now we got to worry about this is negative. That means they have to subtract to make that +1. Well, at least knowing this is positive means my bigger numbers are always the positive number and my smaller numbers are going to be the negatives. Well, that's leaving me with 71. That ain't right. 12 minus 6. That leaves me with 6. That's not going to do it. I need some numbers that are a little closer together. So we might start thinking through some things. I don't know. Maybe 36 times 2. That's not going to work. That's, 34 once we subtract. So maybe the smart kid's sitting there thinking, man, why doesn't he just put 9 times 8? So +9, -8. They subtract to make that +1. So these are the two numbers we're going to go with. 9 times 8 makes the 72. 9 minus 8 makes the +1 that's kind of hiding right here. So let's move on, you say. Move on we shall. 12x squared goes over here, -6 over here on the right side. We're going to split my middle term into my two numbers I found over here, plus 9x and minus 8x. Don't forget the x's on these guys. Makes a very big difference as far as what we're going to do moving forward. So, factoring it by parts. 12 and 9, what have they got in common? 3. X squared and x. Give me an x. Alright. 3 times 4 makes that 12. X times x makes the x squared. 3 times 3 is going to make that 9. So already I've kind of got an idea of what it is that I'm looking to get in this parenthesis group over here. I'm trying to get that 4x plus 3. Another weird thing that happens here. We've got negative signs. Whenever that front thing here has a negative, that's always going to bounce out and stay on the outside. It's just what we do. So I'm going to put that negative sign. That's a pretty ugly negative sign. There we go. Let's make it nice and simple. There's my negative. So what do the 8 and the 6 have in common? Well, 2. Now when I take that negative sign out, it's kind of like pulling both of those. Both of the negative signs come outside. That means this one's going to change. So when I put my 4x here, this is going to be plus 3. And hey, look at that. We got a match. We got a winner. Man, it's just so exciting. So I've got my 4x plus 3 as one of my groups here. What's my other one going to be? 3x. And again, don't leave that negative sign behind. And there's our final factored groups. Man, this is cool. So, what we're doing here, we're taking that front number times our back number. Looking at what kind of things multiply to make it, but also add or subtract to make that middle term. Split it out, factor in parts, and put your stuff together. Seems pretty scary, but all these parts are things you've done before. It's alright. Example number 3. I'd really like it if you hit pause right now and gave it a try. I'm going to work through it anyway so you can kind of check and see if you're on track, but it's always helpful in math to find out where it is that you're making a mistake and where you get stuck, rather than just following along all the time. So give example 3 a try. Multiply 8 times 3, get my 24. What multiplies to make 24? 24 and 1, maybe a 12 and a 2. Again, this is positive, so they're both the same. We're trying to add up to an 11 here. How about 8 and 3? They make an 11. But since this is negative, that means both of these have got to be negative to make that negative 11. So I've got my 8x squared. Gonna take this and do our split. Minus 8x minus 3x and plus 3 from my back term. So we've got our brought down, and our 11x is split. So back to factoring some stuff by some parts. Wow, if we don't get that that's an 8x that they have in common, then we're in trouble. Need my x and minus sign, and well, that's just going to be a 1. Sometimes the easy ones like that 1 are what gets us in trouble. I see this negative sign right here, and the first thing I'm going to do is write it out. I need that guy outside. What do 3 and 3 have in common? A 3. X. Am I going to use the plus sign? No. I brought my minus sign on the outside. That means this guy's got to switch and change to minus 1. Otherwise, these guys aren't going to match, and we're not going to get my x minus 1 term. And my last term comes from that 8x and that minus 3. Make sure you get them both in there and you get that minus sign. Otherwise, it's a sad, sad day in mathematics land. Alright, 8x minus 3 and x minus 1. Example number 4, you're all on your own. Do amazing things. I know you can. So, last little bit of stuff that we're kind of getting through here. Difference of two squares. ax squared minus bx squared. Oh, I threw all kinds of a squared minus b squared. I'm sorry. Just used to having x's on the end of things. This is something that you should kind of vaguely remember from a couple of days ago. I'm sure your teacher was telling you, hey, this is one of those patterns that's very good and helpful for you to know. What it's going to do is it's going to get us in a situation where, hey, we see these two things. There's just two stuff here. Box method's looking like kind of weird. How do I do AC method with this? There's like, I don't know. It just doesn't make as much sense. Well, it's going to be a difference of two squares. 9 is a nice perfect square. 16 is a nice perfect square. So we just start thinking about the square roots of those things. Well, what makes 9x squared? 3x squared. How do we make that 16? Well, 4. Got that minus sign in the middle, so we just kind of split it into the plus minus groups, and we're good to go. So here's z squared minus 36. What makes the z? Squared. Well, a z plus minus, what's the square root of 36? 6. So z plus 2 and z minus, or z plus 6, z minus 6. I swear I say 2 because my z's look like 2's until I get that slash in there. Alright, let's take a look at this one. We got our plus and our minus. Here, the 100 might be a little bit easier to think about with our 10 and our 10. Well, how do we make that 81? Well, it's going to be 9. How do we make a y squared with a y? 9y plus 10, 9y minus 10. Nice and easy. So if you kind of got those patterns from before, it's going to work out okay. If not, well, then you're going to struggle with factoring these other ways. I think you can give these two a try here on your own. I'm positive it's going to work out for you. Alright, last guys that we're going to look at here is our greatest common factor from when we got to pull a monomial out in order to factor things. So we're looking at 72 and 50. Pull that 2 out and bam, all of a sudden we've got something that looks familiar. Get our difference of two squares and we're good to go. So we're going to pull a number out and it just kind of hangs out there on the outside just waiting for you. Oh, I'm going to run out of time. Sorry, I'm going to have to split this one. So example number 9 we'll take care of in the next little part right after this. So go ahead and click over to the next video.